Good afternoon, class. Chapter 3, Derivatives, Section 3.8, Differentials and Linear Approximation, Part 2. Example 3, the radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. Use differentials to find the approximate change in the area of a cross-section of the vessel. This is a word problem, application problem. As we read the question, the area of a cross-section looks like this. It's a circle. It has some radius r, and more specifically at this point, r is 1.4 millimeters. Some drug causes it to shrink to 1.3. This is a new circle with a new radius, which is in this example 1.3 millimeters, giving rise to the difference between the two, which we call it dr or delta r, or the change in the radius, which in this case is 1.3 minus 1.4, which makes it negative 0.1 millimeters. So r is 1.4. The new radius is 1.3. Their difference is negative 0.1. It's important to understand it's changing from 1.4 to 1.3. It's shrinking, so you have to mention the negative sign. The area we should know to be pi r squared, and we are interested in approximating the shaded region. That's dA. So what is given? The radius is 1.4 millimeters. Then the new one is 1.3. Their difference, we call it dr or delta r, or negative 0.1 millimeters. We know the area is pi r squared from algebra geometry, and we are interested in approximation, and that means find dA. By the way, in calculus approximation, that's what it means, differentials, because in some instances they may not mention that. If they say just approximate the change, that's what they mean. And so you want to approximate the shaded region. So having said that, I want you to know that f prime is dy dx, and therefore a prime of r is dA dr by the same token. dy is f prime of x dx, so dA is the product of these two as well. So a prime of r dr, we are going to find dA. So here's a equals pi r squared. We want dA dr. We start with pi, which is just a number, and don't change that. Then r squared becomes 2r, because you are dealing with r being the independent variable. So the answer is 2 pi r. That is dA dr. So dA is the same thing times dr. We are going to plug in. R is 1.4, dr is negative 0.1. It's an easy calculation. The product of these two is 2.8. This makes it negative. This makes it negative 0.28 pi. And the units of the area, millimeters squared, units of the area. Now, you can put it into a calculator with a bunch of decimals if they ask you. If they don't, you're done here. You always show the exact answer with the pi. Now, what does it mean? The area of the cross section of the vessel is decreasing by this much, 0.28 pi millimeter squared. Notice over here we have to put the negative. But if the decreasing is mentioned, or even over here, if there's a decreasing, then you don't need a negative. How do we find the exact? The exact is found just like we would find it here, delta y. So we find delta y, and it's actually easy. The area has the formula pi r squared. So we plug in 1.4, we plug in 1.3, and the difference is the answer. And of course, pi r squared, pi 1.3 squared minus pi 1.4 squared. I have factored the pi out, and it's negative 0.27 pi millimeter squared, very close to what you have here, everybody. So a quick recap. Use differentials to find the approximate change in the area. That means find this shaded region. Obviously, I'm going to go with the exact first. We can find the area of the larger one, the area of the smaller one using the formula pi r squared. Their difference is the answer. And approximation, we go with dA, which is a prime of r dr, one step of differentiation, and 2 pi r dr plug in. A bacterial colony has a population P of t equals 20 t over 10 plus t squared in millions. This should be familiar, everybody. T hours after a nutrient is introduced. Use differentials to approximate the change from t equals to t equals 2.4. Again, the key is the approximation because sometimes they don't mention the differential. And of course, t is 2. The new one is 2.4. Their difference positive 0.4. That means 2.4 minus 2 equals 0.4 is dt or delta t, and we want dp. Which means given p of t, we know how to find p prime, which is dp dt. Given p of t, we know how to find p prime, which is dp dt. And we want dp, which is the product of these two. Again, by the same token as this line for f prime of x is dy dx, dy is f prime of x dx, and dp is p prime of t dt. So the very first step is the calculus step of differentiation. And to differentiate this, you need the quotient rule, everybody. F over g. So we need f prime g minus g prime f over g squared. So f prime, so we want p prime of t, which is dp dt, and f prime starts with 20. Times g, 10 plus t squared. Minus g prime, the derivative of the bottom is simply 2t, times f, 20t, over g squared. So put this in a parenthesis and square it. And that's done. We are going to simplify the numerator of it. Distribute, we get 200 plus 20t squared minus 40t squared. These two add up. We get 200 minus 20t squared in the numerator. So that's dp dt. What is dp? The same thing, times dt. Replace the t with 2 and dt with 0.4. So we get 200 minus 20, 2 squared over 10 plus 2 squared times 2 times 0.4. This is 4 times 20 is 80. This is 4 plus 10 is 14. So the numerator here is 200 minus 80 or 120. This one is 10 plus 4, 14 squared over 196. Divide this one by this one times 0.4. You get 0.245 millions of bacteria, which means 245,000 bacteria. It's an approximation, everybody. From t equals 2 to t equals 2.4, there is an increase in the number of bacteria by this much. What about the exact change? We want delta P. How do we find delta P, the exact change? Well, plug in 2.4, gives you the population at t equals 2.4. Plug in 2, gives you the population at t equals 2. The difference is the answer. So P of 2.4 minus P of 2, and I've calculated for you, it's 0.189, and this means 189,000 bacteria. Okay. Example 5, use differentials to approximate 51 squared. How do we do that? First, we have to come up with a function. And the function you come up with, it's very simple. Read this, 51 squared. The operation that is taking place is the squaring operation. So f of x must be x squared. Then the second step is to choose a number x close to 51 for which squaring is easy to compute. What would be the closest number to 51, class? that you can easily square it? Anyone? $50 becomes 2,500. The way you square a number that ends with 0, you square 5, you get 25, and this one, if there is 1 0, just multiply it by 2 zeros. If there are 4 zeros, multiplied by 8 zeros. That's how you square it, which creates delta x or dx of a 51 minus 50 or positive 1. What does it mean? We may not know what's 51 squared, but since 50 squared is 2,500 and dx is positive, then 51 squared must be larger than that. On the other hand, if the question was asking for what is 40, let's say 9 squared, then I hope you realize dx is -1, which means 49 minus 50 is -1, and we know it's small. Also, I remind you what happened in algebra when they were teaching you a plus b squared, which is a squared plus 2ab plus b squared. They probably mentioned one of the applications is to do this one in your head. 50 plus 1 squared is 50 squared, which is 2,500. 2 times 50 times 1, which is 100, 2,600. 1 squared, which is 1, is 2,601. In other words, they may have mentioned this to you. And that means anyways, you can calculate this easily. So this is the identity that was used in algebra. In any event, this is a different methodology. So in this case, we are looking to find f of x plus delta x, which is f of x plus dy, and we have f of x, we are going to find dy. Let me erase my word. And dy, remember, you take the derivative first in order to get to dy. First, you have to get to dy dx, which is 2x. Dy is f prime of x dx, so therefore 2x dx. And now we put it in here, which means x squared plus 2x dx. Therefore, 51 squared can be approximated by f of 51, this one, which is f of 50 plus 1, which is 50 squared plus 2 times 50 times 1. This is 2,500, this is 100, and the answer is 2,600. As I mentioned, the exact answer is 2,601. Obviously, they are extremely close. The reason is because delta x or dx is very small compared to x. We are done. However, I want to remind you, linearization refers to finding the tangent line. So if you find the tangent line and evaluate it at x equals 51, it must give you precisely the same answer. So as you do your work, your assignments, they may ask you for this method or this method or both. So the tangent line L of x is of interest to us for the function y or f of x equals x squared at x equals 50, which means if you plug this into the original function, you get 50 comma 2,500 x and y. If you plug it into f prime of x, you get the slope 100. y minus y1, that means y minus 2500 equals m100. X minus x of 1, x minus 50. And if you plug in other words, distribute, and then move this by adding 2500 to both sides, you get y or L of x, the tangent line, equals 100x minus 2500. Again, I can't emphasize this enough. This means the tangent line. And if you plug in 51, because that's what we want, so 51 squared is approximated by L of 51, 100 times 51 minus 2500, you will get identical to this answer, 2600. You must. That is because it's a different method of approaching the same thing. Okay, the concept of a differential. Okay, so differentials and linearizations, they must give us the same answer, identical answer. Now, for example, 6, use differential to approximate square root of 27. So the very first question is, okay, what is the function here? Read, it says square root of 27. So what operation? The operation of square rooting, therefore, f of x is square root of x. The second step is a number. Choose a number x close to 27 for which the square root is easy to compute. The closest number to 27 that you can take a square root of easily. Anyone? What would be the closest number to 27? 25, because square root of 25, we all know it's 5. So going from 25 to 27 adds 2, therefore dx or delta x is positive 2. Meaning, I don't know the square root of 27, but I do know it's larger than square root of 25, which is 5. On the other hand, if the question was, what is square root of a 24? Remember, dx is -1, which means I don't know what square root of 24, but must be smaller than square root of 25, meaning 5. So we want f of x plus delta x, which is approximated by f of x plus dy, and we have f of x, we do not have dy, and to find it, we're going to change the square root of x to the power 1/2 and differentiate using the power rule. One half x to the power of 1/2 minus 1, it's -1/2, 1/2 x to the power of +1/2, or 1/2 square root of x. I'm assuming everybody can do that. And of course, dy is the same thing times dx, which gives rise to the following. F of x plus delta x becomes the function square root of x, and dy 1/2 square root of x dx. We want square root of 27, and square root of 27, it's approximated by f of 27, we mean this one, which is f of 25 plus 2, which means replace the x with 25 and dx with 2, everybody. Of course, square root of 25 is 5. Everybody knows that. And we drop the 2, we get 5 plus 1/5, or 5 and 1/5, or 5.2. If we put it into a calculator and approximate it, again, this is an approximation because this is an irrational number. It never ends, but of course with a lot more decimals. I hope you see that. With the first decimal, we get 5.2. Even with the second one, if you want to round it to the second, decimal, 6 makes this 10, 10 makes this 0, makes this one 2, and becomes 5.20. So if they say 2 decimals, you must write 5.20 because it does have a meaning that is different than 5.2. So it's that good. It's pretty close. But as I mentioned, linearization refers to the tangent line. And what we want here, we want the tangent line L of x for the same function f of x equals square root of x at x equals 25, which means if we put the x here, we get 25 comma 5 as the pair. And if we put it here, we get 1 over 2 times 5, or 1 over 10 as the slope. Y minus y1, that means y minus 5 equals m 1 over 10 x minus 25. If you distribute, you get 1 over 10 times x minus 25 over 10. And you should know 25 over 10 is the same as 5 halves. If you add 5, you get positive 5 halves. So L of x is 1/10 of x plus 5 halves. And square root of 27 is approximated by L of 27, the linearization, and it becomes 5 and 1/5. In other words, if you put 27 here, you get 27 over 10 plus 5 halves. (25 over 10), which is 52 over 10, which is 5 and 1/5, or 5 and 2/10. Remember that, which is 5 and 1/5. So this number must be identical to this number. Whether we go with the differential or the linearization, we will get the same answer. Example 7, measurement error. In a manufacturing process, a ball bearing must be made with a radius of 0.6 millimeters, with a maximum error of plus minus 0.015 millimeters. Normally, they use both of it. That means this is what we want. If it goes up by this much or down by this much, it's okay. Use differentials to estimate the maximum error in the volume of the ball bearing. As you can see, it's in spherical shape, which means we should know the volume is 4/3 pi r cubed. So what it means, class, is that the radius is supposed to be 0.6, the radius of each one of those, okay? If it's a little bit less by this much, that means 0.6 minus 0.015, that means 0.585, it works. If it's little bit larger by this much. That means 0.615, it works. But if it's beyond that, what happens when it's beyond that? If it's way too large, it gets stuck. If it's way too small, it is loose and it falls off. That's the meaning of it. So R is 0.6. Delta R or dr, the maximum error in the radius is considered delta R or dr. We are supposed to know the volume is 4 times power cube. We want dV. So we're going to write the given as follows. R is 0.6 millimeters. Delta R is plus minus 0.015 millimeters. The volume, this is not given. We are supposed to know that 4 times power cube. And we want dV. So the volume is 4 times power cube. dV is missing. And to find dV, just like here, for f prime of x dy dx has to be found first. For this v prime of r or dv dr must be found first. And please understand, you keep this intact because it's just a number. And you differentiate r cubed, which gives you 3r squared. These two cancel each other, 4 pi r squared. So dV is the same thing times dr, 4 pi r squared dr. Over here says replace the r with 0.6 and dr with plus minus 0.015. We do that, we get plus minus 0.0216 pi. We should leave it like that. That's an exact answer for this calculation. An approximation of that, however many decimals they ask, you put it plus minus 0.0678584. So the approximation says it goes either by this much up or down. That is the plus, and the meaning of a plus, up minus down. Plus means increasing, and minus means decreasing. Now, this is an approximation. How do we find the exact answer in the volume? Delta V represents the change in volume. By the way, the units would be the units of the change in volume or just the volume, which is a cubic millimeters. And so it's very simple. We know the formula is 4 thirds pi r cubed. Plug in 0.6. You find the volume that you need to begin with. And then go with the upper one would be 0.615. Replace the R and calculate it. That gives you the volume for the upper hand. Their difference is the answer. For the smaller one, 0.6 minus 0.015 becomes 0.585. Plug it in. So 0.615 cubed. And by the way, I factored the 4 thirds pi, and you do the same thing for the bottom. 4 thirds pi, 0.585 cubed minus 0.6. And I left it for you to finish it. And by the way, the two, if you take the absolute value, they will not be the same, unlike here that they are the same because it's nonlinear.